Hello and welcome to another 3D printing video. This video's topic is materials for FDM 3D printers. FDM 3D printers use filament as their material for printing, and the filament's size was originally 2.85 millimeters, or they tried out with 3 millimeter filament also, but they quickly noticed that it wasn't usable at all, because in the 3D printers they used this tube to guide the filament into the 3D printing head, and the tubes at that time were mostly 3 millimeters in inner diameter. So using a 3 millimeter filament in a 3 millimeter inner diameter tube causes a big problem, because there won't be enough space for the material to slide smoothly, and because the manufacturing methods or the tolerances obviously can't always be spot on the 3 millimeters. So it might be a bit over, so it will get stuck quite easily. So sensible thinking quickly gave the idea to slightly use a smaller filament size in the materials. So that's why the industry settled on 2.85 millimeter material diameter. And that was used for like 10-15 years, or at least in the 2010 era. The 1.75 millimeter material started to rise. Why would you use the big one nowadays compared to the 1.75 millimeter? Is that there are some advantages still on the 2.85, or some things that still restrict the change over the 1.75 millimeter materials. Is that there's still some manufacturers that are committed to the 2.85 millimeters, like Ultimaker and Shortrax or Stratasys, that still use the 2.85. Sorry, Shortrax might not be one of those, but at least Ultimaker and Stratasys still use 2.85. And then another reason is that some Bowden type 3D printers they work a lot better with the 2.85 millimeter than the 1.75 millimeter diameter material. And that's about it. I mean, just a few reasons. And okay, maybe some flexible materials might be a bit more usable in the 2.85 millimeter diameter than the smaller one. But those are basically the major reasons. Some manufacturers don't just want to have to transition just yet. And some printer manufacturers still use, and more the industrial printer manufacturers still use the bigger diameter materials. Okay, but what about what type of materials still are available? I mean, what type of materials you can print with an FDM 3D printer? You can print durable materials, you can print flexible materials, you can print conductive materials to a certain stage. These are like comparable to your copper wire conductive, but there's some conductivity. Let's put it that way. It depends totally on the manufacturer. And then there's antibacterial materials, and then there's sculptable materials that you can, after it's been 3D printed, you can sculpt it with, like, you will sculpt with clay. And then there's metal materials. They're like basically plastic that have metal powder inside of them, like 20 to 30%, or some might have even more. With some of the materials you can make metal parts by burning the plastic off with an oven, by sintering the part. And then there's the glow-in-the-dark materials, just for the look purposes or for guiding purposes in some sort of emergency situations. And then there's the industrial materials like the Peak and the Ultiman, Pay, and etc. The ones that you really can't print with a desktop FDM 3D printer. But let's go over some of the basic materials that you can print with an FDM desktop printer. First, and the most significant one, is PLA. What is PLA? It's polylactide. It's made out of cornstarch or sugarcane. It changes by the manufacturer which they use. It's used widely in biodegradable plastic products other than 3D printing. And this is the most common 3D printing material. This is the material that you want to print those good-looking prints. That they don't have to have the durability or rigidity. They just have to look good. You should use this material. The printing temperature is like around 200 Celsius on the print head and around 50 to 60 on the print bed. So what are the pros and the cons on this material? Well, the pros are it's very easy to print. This is the most easiest material you can print with. This is the most basic material. And it doesn't require a heated bed. And then there's the accuracy. You can get very detailed prints out with this material, even before you have even calibrated your 3D printer. This is the material you get good results with. It's easy to post-process. You can add you can sand it. You can add different plaster, for example, on it. You can use different glues on it, and you can easily paint it over. Very flexible in that type of cases. And it's it's non-toxic when it's printed, so there's no toxic emitted compared to some of the other materials that we have listed here. And the color range with this material, it's huge. Any possible color that you can imagine is basically available in this material. Okay, there are some restrictions again, but mostly it's available. And there are some material manufacturers that can make your custom color if it's not available in their collection. And with this material, it has high tensile strength, but it doesn't have good impact strength, or it doesn't stretch that much. And the temperature resistance is quite bad because it's like under 60, around 60 degrees Celsius. And then it starts deforming. And there are some cases that if you use this part made of this material, you place that part in your car, and in the hottest summer day, it can melt and drop your iPad, for example. If you have printed an iPad holder with this material and use it in your car. The chemical resistance isn't that good, and the UV light resistance isn't that good. So it's just for showcase purposes, basically, and for basic stuff. I wouldn't make anything that you will have to depend your life on with from this material. It's not that durable. Then there's the ABS. Then there's ABS. Acrylonitrile butadiene styrene. That's a hard word. The most basic material, or most basic plastic that everyone knows. And the main reason for that is shown in the picture. So it's the Legos. Everyone knows Legos, and Legos are made out of ABS. And this plastic is completely made out of chemicals. And is very, very widely used in the everyday items in a common household. From kitchen to bathroom items, or to kids' toys, as you can see here, and etc. Or even car parts are printed, not printed, but made out of ABS plastic. This is, again, one of the top trio of 3D printing materials. On the print side, on the print temperature for this material is like 230 to 250 Celsius, and the heat bed is definitely required with this material, around 80 to 95 degrees, or even 100 degrees Celsius. You have to use a heated bed with this material. What are the pros? It has high impact strength. It has good temperature resistance. We talk about like 90-95 degrees Celsius. It has good chemical resistance, except for acetone. It dissolves in acetone, and in the picture you can see that there's three parts. All of them are printed in ABS, and one of them has been post-processed with acetone. It's the one that shines, obviously. So acetone pretty much melts ABS plastic. So that's why it said that post-processing is so-called easy. Of course, this is a toxic method, and you should have precautions using acetone, and be very careful with these. What are the cons? It's not an easy material to print with. It's easily warpable, and it has some difficulties to stick into the bed. So it warps when you print bigger pieces, because it starts to try to pry itself off from the print bed. And once it's pries one corner off, you won't have a flat part anymore, and your part basically fails, or you can detach itself from the bed and mess up your whole printer. So there's some difficulties getting this material to attach to your print bed. And one bad thing, again, also is that it's very toxic when printing. It emits this nasty smell that's very bad for your lungs, so you shouldn't be in the same room, or if you're in the same room, make sure that the room is very ventilated, so the air doesn't just sit there, so it goes around and ventilates the fumes. And it's not very usable in outdoors. UV light is bad for ABS. It doesn't enjoy UV light, so to say. I said earlier that, the last slide I said, or the slide before that, I said that the ABS was one of the trio, and this is the third one of the trio, PETG or PETG. Polyethylene terephthalate. That's a mouthful. PETG is the same as that PET, but there's some glycol added for flexibility. So there's a chemical added for the flexibility. It's again used. This one is also used widely in common day items, everyday items. For example, all the soda bottles that you buy from the shop are made of PET plastic, and this is one of the trio materials that I mentioned. This is an excellent replacement for ABS if you have no possibility to print ABS safely because of the fumes, toxic fumes. And it's very rigid, a good material to have. The printing temperature is around 225 to 240, 250. Depends on the manufacturer again. And again, you need a heatable print bed with this material. Around 70 to 90 degrees Celsius for the print bed. And what are the pros for this material? Temperature resistance around 85-90 degrees. It's so-called food safe material because the material itself is food safe. It has good chemical resistance. It has good impact resistance. It's very easy to post-process. It's very stiff, so to say, and it's odorless when you're printing. So there's no odor emitted when you print with this material. And easy to post-process meant that you can sand it and you can do all the same post-processing methods that earlier with the earlier materials, but acetone doesn't work with this material. What are the cons? It's so-called hard to print. It has warping issues or getting it to stick to the bed issues also, but not as bad as warping issues with ABS plastic. The material has bad bridging abilities unless you have optimal cooling and really calibrated 3D printer. So they will have these strings and etc. So this material can also destroy your print bed. It can rip pieces of glass out of your print bed if the nozzle is too close to the bed when you print. So you will need to raise the nozzle a bit above the print bed when printing with this material. It needs to be a bit higher than with other materials. Another one, ASA, acrylonitrile styrene acrylate. Another chemical material. This is similar to ABS. One difference is that this material has UV resistance, really good UV resistance. And this material is widely used in the automotive industry. So not in everyday items basically, but in the automotive industry. And the printing temperatures are basically the same with the ABS. So no difference there. What it has basically the same things exactly as ABS. So impact strength is good, temperature resistance, it falls a bit below ABS, around 90 to 95 degrees, depending again on the manufacturer. Some manufacturers promise more temperature resistance because they use different combinations of the chemicals used in creating the material. Chemical resistance is good. Again, acetone works with this material also. Post-processing, again, so-called easy. UV resistance is good. What about the cons? Exactly the same cons as with the ABS. So it warps from the bed, and it's not as toxic as ABS, but it's still toxic. So you shouldn't breathe in those fumes that come out of the printer. Then there's the support materials. HIPS, PVA, and breakaway. These are materials that you use in a 3D printer that has two extruders or two nozzles. So there's the main material that you print with, and then there's the support material that you just use for surfaces that are like hanging in the air. So that's the case when you need support materials placed in the print. And if you don't have a two-nozzle 3D printer, you will print the supports out of the same materials that the main material is. And you will have to mechanically move those and sand the surfaces if you want it to look good, and etc. But if you use support materials, you can get clean surfaces, like shown in the picture. It has used this support material called breakaway, and this whole surface was supported by that material, and the surface quality is quite good. It's better than with the normal material, the same PLA that's used in the main part, but it's still not superb, so to say. And what's the difference between the HIPS, PVA, and breakaway? Well, HIPS is a material that dissolves in limonene, and it's used with ABS materials. PVA is a material that dissolves into water, warm water especially, and it's used with PLA. Then there's breakaway that just easily comes off. You have to mechanically remove it, so there's no chemical or water way, so to say, to remove it. So you have to use it with a knife or pliers and pull it off. That can be used with PLA, ABS, nylon, and CPE. I have to mention that there are some PVAs and HIPS that also work with obviously different materials than with mentioned there. So there is PVA that works with PETG and ABS, but the mostly common friend for PVA is PLA. Printing temperature for these materials is around 210 to 240, and heated bed is like 260 to 110. HIPS is the one that requires the high temperatures, the 240 degrees on the nozzle and 110 on the print bed. So what are the pros on these materials? Well, bottom surfaces are pretty when you print with these support materials and you support them on the floating of the air. Having an easy way to get rid of the support materials, or the supports using the parts. For example, if you have like orifices on your part, you can't get normal support out of there. You have to use the dissolvable supports to remove that. Okay, what are the cons? Well, it requires a heated bed. There's high temperature. Okay, that's not pretty con, but the chemicals are required, so you need limonene. And one bad quality, for example, about PVA, it's very hygroscopic material. If you take it out of the box and start the print with it, the print will come out fine. And if you leave the printer there and don't do anything with it, still the material, so it's still the PVA in the machine, and then you come back a week later and try the same print, you will notice that it fails miserably. And you try it again, and it fails again, and you try it again, and it fails again. It's an endless cycle. So it sucks so much moisture out of the environment, so that it's not printable anymore. So you have to dry it, for example, in an oven or a dryer. These are filament dryers, and then it's usable again. So you have to store it in a place that doesn't get any moisture. What about other materials? For example, nylon. It's a polyamide. It's widely used material in different sectors. Very, very widely used. Used in automotive, used in industrial sectors, and used in anything you can basically come up with. Nylon is used there. Maybe not in the toy industry, because the toys don't need to be so rigid or durable. And there's like several different variations of this material, so different mixtures of this material. Printing temperature are like 220 to 255, and you need a heated bed for this material. What are the pros for this material? It has high impact resistance, it has good temperature resistance, around 100 and 120 degrees even, and it has good chemical resistance, it's very stiff, it's odorless when printing, and it has very, very good wear resistance. What's about the cons? It's very tricky to print. It starts warping easily, just like ABS. And one bad thing, it's hygroscopic. So you need to store it properly after printing or in the same time when you're printing. And it's not usable for moist environments or humid environments as a printing material, at least some of the nylons. There might be variations that are suitable, but some of them are not, because they will still keep on sucking the moisture inside. Then there's polycarbonate, again widely used in the industrial sector. It has high impact resistance, it has high heat resistance, and it bends a bit. It's stiff, but it still bends a bit. And this one has the highest from these materials. This one has the highest printing temperature, 250 to 310. And then there's the heat bed temperature, 80 to 120. Then there's the pros. There's the thermal resistance. It can withstand over 150 degrees Celsius. It has excellent impact strength. It bends without breaking. What about cons? It breaks. What about cons? It's hard printability. It warps easily. It requires a lot of heat for prints to succeed. So, as you saw earlier, 250 to 310. It's again, just like nylon, just like PVA, it's highly hygroscopic. And this one doesn't either fit environments which are moist or humid. Then there's some other types of filaments, like there's the glow-in-the-dark filament, then there's the wood glow-in-the-dark, which are fluorescent material that glows in the dark when emitted with light first, and then put in a dark environment. That's an abrasive material. What does the abrasive word mean in this case? It means that it will eat up the nozzle. So if you have a 0.4 millimeter nozzle and you use abrasive materials for like 1 to 2 kilos, print with that material with your 0.4 millimeter nozzle, I have to say that after 1 to 2 kilos material, your nozzle won't be 0.4 millimeter. It will be more likely 0.5 millimeter or 0.55 millimeter. So it wears out. So you have to use a certain type of nozzle, like steel nozzle or nozzle X or a ruby nozzle with these materials, these abrasive materials. Then there's wood materials, which means that it's basically PLA with 20 to 30% of wood powder. Then metal powder infused materials like copper, steel, or brass. And then there's carbon infused materials like carbon nylons, nylon carbons, or ABS infused with carbon. Then there's the flexible materials, Semiflex and NinjaFlex, those are the names of the materials. And then there's inductive conductive materials that you can do small circuitries with. So what type of manufacturers are there? Like, where do you get it? Who does it? Who works with it? Who creates it? These are just a few examples that we have experience with, that have all proved out to be good ones. No problem with these material manufacturers. All come up with good, solid materials. Each one of them, basically, except for NinjaTech, creates all the materials mentioned in this video. Each one of them creates ABS, PGG, and PLA at least. Okay, not everyone creates polycarbonate or nylons. Okay, but that wraps up this video. Hope you enjoyed it, and see you in the next one.